So we left off the last video just before we graphed f of x, and so graphing f of x, we see a couple things. We see a number out here in front of the cube root. That's our a value, and that a value tells us that it's just going to be a little bit steeper than an a value of 1. And then this plus 1 here means we're going to go to the left 1 from the parent function cube root of x. And the plus 2 means we're going to go up 2. And so the hk, the h is -1 and the k is 2. So -1, I'll do this in blue, -1, 2, that's our inflection point on the graph of the cube root function. And that's an important point. The hk is our inflection point, -1, 2. And that 2, again, that causes us to have to move up a little bit higher. So let's go ahead and plug in an x value of 0. 0 plus 1 is 1, cube root of 1 is 1, so 2 times 1 is 2, and we have 2 plus 2 is 4. So normally with the regular cube root function we go up 1 and over 1 and we get the next point. But here we're going to go up 2 and over 1 because the next point is 0, 4. If we go up 2 and over 1 from that point, then we're going to go down 2 and over 1 to get to the next point. So we're going to get a cube root function that's just a little bit wider. It kind of comes in a little bit steeper. And again, that's our inflection point. So you're going to come in flat, and then you're going to kind of go out like that. So there's our cube root function. And instead of trying to graph this function down here, then we're just going to take some points from f, and we're going to plot them on f inverse. So we're going to draw the graph of f inverse symmetrical with respect to the line y equals x. And I'm going to go ahead and draw that line on this one because it's going to help us see the graph better. And let me get this so that it looks right. Okay. So again, all functions and their inverses are always symmetrical with respect to the line y equals x. So if we look at some of the points that I found on the graph of f, I know that they're corresponding points on the graph of f inverse, just we flip the x and y coordinates. Here we have -2, 0, which means we have 0, -2 on the graph of f inverse. -1, 2 becomes 2, -1. And then 0, 4 becomes 4, 0. And the inflection point is going to be the point in the middle. And we can do it like this. And it comes in. Kind of show a mirror image there. You can clearly see it looks like an octopus. Oh, no, yeah, octopus, squid, one of those. Both. But there you have it. There's the graph of f inverse. And then the homework is going to be to do the 2 examples down here, so I'll leave those for you, and maybe or maybe not have a video for those. But either way, I'll have the solutions in class for you. But hopefully that clarifies how to graph a function as inverse, finding the inverse when you have a cubic function, and cubic and cube root are inverses, square, quadratic, and square root are also inverse functions, and so on and so on.